Good afternoon, children. Today we will start a new chapter, that is work and energy. So, first of all, let us try to understand the meaning of work. So, in language of physics, we say that work is done when a force produces displacement in an object. It means when we apply force on an object and the object is displaced from its position, then work is said to be done. If I apply a force on wall and as you know, you just apply a lot of force on the wall, but you are unable to displace it. So in that case, we will say that yes, work done is zero because there is no displacement in the wall. Although we get tired in doing so if continuously you are applying force on the wall, because there will be a hidden work done. Hidden work done, it means your muscles are stressed when you apply force that is not visible from outside. So there will be a hidden work done. That's why you get tired if you continuously apply force on the wall. But in language of physics, work done is zero since there is no displacement in the wall. So first question is, what is work? What is work? So you will write in physics, work is said to be done when a force produces displacement in an object. So write this sentence, that in physics work is said to be done when a force produces displacement in an object. Now we will learn some lines from NCERT book. You open page 146 and here it is given a heading work, and then after there is a question, what is work? So you concentrate on book. What is work? There is a difference in the way we use the term work in day-to-day life and the way we use it in science. To make this point clear, let us consider few examples. Not much work in spite of working hard. Then this example, Kamali is preparing for examinations. She spends lot of time in studies. She reads book, draws diagrams, organizes her thoughts, collect question paper, attend classes, discuss problem with her friends and perform experiments. She expends a lot of energy on these activities. In common uh, parlance, she is working hard. All his hard work may involve very little work if we go by the scientific definition of work. You are working hard to push a huge rock. Let us say the rock does not move despite all the effort. As I am saying that we are applying lot of force on the wall, and after applying lot of force we are unable to displace it. So you are applying your effort, maximum effort to displace the rock, but you are not able to displace it. You get completely exhausted. However, you have not done any work on the rock, as there is no displacement of the rock. So if there is no displacement in the rock, in terms of physics, we will say that work done is zero. You stand still for a few minutes with a heavy load on your head. You get tired, you have exerted yourself and have spent quite a bit of your energy. Are you doing work on the load? The way we understand the term work in science, work is not done. So if we take a heavy load on our head and we stand for a long period of time, or even for 10-15 minutes, you get tired. But in the language of physics, the work done is zero because the displacement is zero. You climb up the steps of a staircase and reach the second floor in a building just to see the landscape from there. You may even climb up a tall tree. If we apply the scientific definitions, these activities involve a lot of work. In day to day life, we consider any useful physical or mental labor as work. But mental labor is not work in terms of physics. Activities like playing in a field, talking with friends, humming a tune, watching a movie, attending a function are sometimes not considered to be work. What constitutes work depends on the way we define it. We use and define the term work differently in science. To understand this, let us do the following activity. Now, activity is given, activity 11.1. I am reading this activity. We have discussed in the above paragraph a number of activities which we normally consider to be work in day-to-day life. For each of these activities, ask the following questions and answer them. What is the work being done on? What is happening to the object? And who or what is doing the work? So, if you ask these questions, what is the work being done on? What is happening to the object, whether the object is displaced or not, and who or what is doing the work? So, if you get answers of these questions, then in yes, then you can say that yes, work is being done. Now we will discuss the scientific conception of work. So scientific conception of work, I am reading this topic on page 147. To understand the way we view work and define work from the point of view of science, let us consider some situations. Push a pebble laying on a surface. The pebble moves through a distance. You exerted a force on the pebble and the pebble got displaced. In this situation, work is done. So, if you apply a force on a pebble, it is displaced from its position. It travels some distance on the surface and then it stops due to friction. So, pebble is displaced, so work is being done. Then lift a book through a height. To do this, you must apply a force. The book rises up. There is a force applied on the book and the book has moved, hence work is done. So, if I apply a force just to lift a book, so I am doing some work to lift the book. How much work I am doing? At least I am applying a force which is equal to weight of this book. And in previous chapter we have learned that the formula for weight is mg. So it means the force which I am applying to lift the book will be at least equal to weight of the book, and since book is raised through a height h, so work is being done here. If any one of the above condition does not exist, work is not done. This is the way we view work in science. It means a force is needed and the object must be displaced through a distance. Then work is said to be done. A bullock is pulling a cart. The cart moves. There is a force on the cart and the cart has moved. Do you think that work is done in this situation? Yes, work is being done because in a bullock is pulling a cart. So they apply a force in downward direction on the road surface. As a result, the cart moves. Now we will also discuss the types of work done. One thing is clear that uh, force is needed for work done and the object must be displaced. So you write that is a force is needed and object must be displaced. For work is to be done. So these two things are compulsory, that a force is needed to displace the object and the object must be displaced. Then we can say that yes, work is done. Now we will discuss the types of work done. First, positive work done. Positive work done means, suppose we are applying a force in forward direction and the object is also displaced in the direction of applied force, then work done is positive. So if displacement takes place in the direction of applied force, then work done is positive, isn't it? Then negative work done. Negative work done means just opposite. It means if you are applying force in forward direction and the displacement takes place in backward direction, just opposite. Can you think this type of situation? Can you give any example of negative work done? You might have seen the wells in which pulley are provided to take out a bucket of water. So if you have seen how we take out water through pulley, we are applying force in downward direction on the rope and the bucket is moving upward. So this is a example of negative work done. It means you are applying force in downward direction and the displacement takes place in upward direction. So negative work done we will write if displacement takes place opposite to the direction of applied force, then work done is negative. For example, if we take out a bucket of water from a well through a pulley, and for positive work done, there are so many examples where we are applying force and in forward direction and the object also displaced in forward direction. Now we will derive an expression for work or work done. How we can measure work. So expression for work done or work done by a constant force. Work done by a constant force. So I write a few lines. Write let a constant force F. Let a constant force F acts on an object. Let a constant force F acts on an object. Next sentence. Let the object be displaced. Let the object be displaced through a distance s, small s. Let the object is displaced through a distance s in the direction of applied force. In the direction of applied force. Third sentence, let W be the work done. Let W be the work done Next sentence, we can define work to be we can define work to be equal to product of force and displacement. Product of force and displacement. That is, work done is equal to force into displacement. And symbolically we can write it as W is equal to F into S. So this is important expression. You have to use this formula many times in numericals, that work done is equal to force into displacement. F stands for force and S for displacement. Then the SI unit of work. So SI unit of work is joule. Sometimes you get a question that define 1 joule. So how we can define it? Look at this expression. The SI unit of force is Newton. The SI unit of displacement is meter. So we can, from this expression, we can write 1 joule is equal to 1 Newton into 1 meter. It means if 1 Newton of force produces a displacement of 1 meter in an object, then work is said to be of 1 joule. So write, thus 1 joule is the amount of work. Thus 1 joule is the amount of work done. 1 joule is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter in the direction of applied force. Or you can write it in this way also, that if a force of 1 Newton displaces an object through 1 meter, in the direction of in this way you can also write. If a force of 1 Newton displaces an object through 1 meter, then work done is said to be 1 joule. Simple. Obviously, the direction of force and the direction of displacement are same. So must learn it. Definition of 1 joule, SI unit of work. And then tell me, work done is scalar quantity or vector quantity? Because force is a vector quantity, as you know. Displacement is also vector quantity, but you have to read about it in higher classes, not now. That cross product of two vector quantities is a scalar quantity. So you must know that work done or work is a scalar quantity. Write it. Completed. Now we will discuss some of the questions, children. First, open page 148. Page 148. Question number 1. A force of 7 Newton acts on an object. The displacement is, say, 8 meter. So let us solve this question. Page 148, question number 1. Force is given 7 Newton. And displacement, it means S is 8 meter. In the direction of the force. diagram is also given. Let us take it that the force acts on the object through the displacement. What is the work done in this case? So, as we have derived an expression that work done is equal to force into displacement. So, it will be 7 into 8. So, 56 joule. So, 56 joule of work will be done. So, very simple numerical. Now, after the numerical, some situations are given. Consider another situation in which the force and displacement are in the same direction. A baby pulling a toy car parallel to the ground as shown in figure 11.4. The baby has exerted a force in the direction of displacement of the car. In this situation, the work done will be equal to the product of force and displacement. In such situations, the work done by the force is taken as positive. So, as we have discussed earlier, if displacement takes place in the direction of applied force, then work done is positive. Consider a situation in which an object is being displaced by the action of force and we identify one of the force F acting opposite to the direction of the displacement S. That is, the angle between the two directions is 180 degree. As I have discussed in case of negative work done, the angle between the force and displacement, we are applying force in downward direction to pull the rope and the bucket is moving upward. So they are making an angle of 180 degree, the displacement and the force. Another example you can take when you apply brake on a moving vehicle. So in that case also there will be a negative work done. So in such a situation, the work done by the force is taken as negative and denoted by a minus sign. The work done by the force is F into minus S. It is clear from the above discussion that work done by a force can be either positive or negative. Now we will discuss some more questions on page 149. When do we say that work is done? So simply when a force produces displacement in an object, then work is said to be done. Second question, write an expression for work done when a force is acting on an object in the direction of its displacement. So now we have derived that expression that W is equal to F into S. Then third question is define 1 joule of work. We have defined already. You must learn it. Now question number 4. A pair of bullocks exert a force of 140 Newton on a plough. Question number 4. Here force is 140 Newton. The field being ploughed and is 15 meter long. Displacement is given 15 meter. How much work is done in ploughing the length of the field? So very simple, same formula. W is equal to F into S. So here 140 into 15. So if you will multiply, so 2100 joule. Must write the unit in your answers. Otherwise half marks will be deducted. So 2100 joule. Now we will discuss the questions in chapter end exercises. Question number 1. Look at the activities listed below. Reason out whether or not work is done in the light of your understanding of the terms work. So, what do you think? First one, Suma is swimming in a pond. So, it may be positive or negative work done. So, work is being done. So, your answer will be yes. Positive work done if they move in the direction of applied force, and negative work done that when they just push the water backward in backward direction and they move in forward direction. So it may be positive or negative work done. It depends on the style of swimming, but work is being done because they apply force and as a result they displaced. A donkey is carrying a load on its back. So work done is 0 because the load is not moved. Load is a weight and weight is the force. So he simply carry the load on his back. So in such a case work done is 0 because displacement is 0. Then a windmill is lifting water from a well. Yes, work is being done. A green plant is carrying out photosynthesis. No work done because displacement is not visible to us at that time. An engine is pulling a train. Yes, work is being done. Food grains are getting dried in the sun. No work done. A sailboat is moving due to wind energy. Yes, work is being done. Now, giving a question as a homework. So, in homework, you will solve question number 18, page 159. Question number 2 also. These two questions are homework. Now we will solve some more questions. So write this question. A laborer having mass M1 of 80 kg carries a bag of mass M2 of 10 kg to the top of a building 98-meter high. Find the work done if acceleration due to gravity is 9.8 meter per second square. Now we will solve this question. So think over it. First, to calculate the work done, two things are needed: the force and the displacement. So let us calculate the force first. So force means load. So force is equal to, as we know, weight, and weight is equal to mg. So here in this case, the mass of labor is 80 kg, and he carries a bag whose mass is 10 kg. So it will be m1 plus m2 into g. So it will be 80 plus 10 into 9.8. So 90 into 9.8. So multiply it. That will be the force. So if you will multiply, so it will be 882 Newton. Then displacement. Height is also known to us, S or H. Displacement is 98 meter. So work done is equal to F into S. So it will be 882 into 98. Now again multiply it. So if you will multiply, it will be how much? 882 into 98. 8 to just 16, 65, then 70, 18, 73, 7, 79. So it will be 86436. So 86436 Joule. So this is another type of question, children. You must practice the solved examples which are given in the book, and numericals are easy so far work done is concerned or work is concerned, and must solve these numericals or the theoretical question which I have given as a homework, and send it to me in my WhatsApp number. Thank you for today. In next class we will discuss about energy.